Hopefully you've downloaded your handout for section 4.1, Law of Sines. Excuse me. This is the last chapter that we will cover completely. The title of this lesson, of this chapter, is Solving Oblique Triangles. An oblique triangle is one that does not have a right angle. So since these triangles don't have right angles, we cannot use sine, cosine, and tangent or any of those other trig functions. That's the bad news. The good news is we got different rules that we can use to help us solve these. The first one we're going to look at, the one we're talking about in section 4.1, is Law of Sines. If A, B, and C are the measures of the angles of a triangle, and small a, b, and c are the lengths of the sides, then this proportion is true. A is to sine of A, as B is to sine of B, as C is to sine of C. The ratio of the lengths of the sides of any triangle to the sides of the angle opposite that side is the same for all three sides. So here's what I want you to do. I want you to get a note card, and I want you to copy down this on that note card. Do that after we've gone through the lesson, or write it on your notes and draw a big old square around it, because we're going to be referring to that a lot. We're going to look at our first example. Given triangle ABC, CD is the altitude drawn from vertex C to the opposite side, creating two smaller right triangles, ACD, BCD. We can use this to prove that this law of sines is correct. The sine of B, of this angle B, would be H over A. The sine of A would be H over B. When you multiply by A here and by B here, you come out with H equals A sine of B, or H equals B sine of A. Therefore, these equal each other. If you divide both of these by sine of A sine of B, you come out with A is to the sine of A as B is to the sine of B, and the other follows likewise. This is the proof of the law of sines. Solving an oblique triangle means finding the lengths of all the sides and the measures of all the angles. This first triangle that we're looking at is side, angle, angle. That's the information they're giving me. They're telling me one side and an angle and an angle. If angle A is 46 degrees, angle C is 63 degrees, and side C is 56, I want you to solve this triangle. First thing that we're going to do is to find the measure of angle B. That's easy. 180 minus the sum of these gives you the measure of angle B, so that is 71 degrees. Now I'm just going to use the law of sines and find these others. 56 is to the sine of 63, as A, because I'm looking for side A, is to the sine of 46. Cross multiply, you have 56 sine of 46 equals A sine of 63. Divide both sides by sine of 63. Put your calculator in degrees, because all of these angles are given to us in degrees. So I'm going mode, turn my calculator on, clear, mode, change to degrees, press enter. Now 56 sine of 46, close parentheses, divided by sine of 63 equals 45.2. So side A equals 45.2. Do the same thing to find the length of side B. 56 is to the sine of 63, as B is to the sine of 71. That's going to tell you that B equals 56 sine of 71 divided by sine of 63. Put that in your calculator. (56 sine of 71, close parentheses, divided by sine of 63 equals, side B is 59.4, and we have just completed our first example. Seems to me that this chapter is going to be much easier than the one we just finished. Turn the page. Example 2, or case 2, they have given us an angle and a side and an angle. We've got a sketch already drawn. We're going to find angle B by adding these two together and subtracting from 180. That tells me that angle B is 96.5 degrees. Then we're going to use the law of sines to finish that. 76 is to the sine of 96.5, as C is to the sine of 33.5. C is going to equal 42.2. Do the same thing. Start with given information, which is 76 is to the sine of 96.5. Now we're looking for side A, as side A is to the sine of 50. Whenever you cross multiply, like we've done on the preceding page, A sine of 96.5 equals 76 times the sine of 50 divided by sine of 96.5. You'll come out with 58.6. Just solved another one. Oh yeah, these are no problem. Then we come to the ambiguous case. Case 2 was when we were given angle, side, angle. Case 1 is when we were given side, angle, angle. But the ambiguous case is where we're given side, side, angle. On your note card, I want you to write law of sines. It's good for angle, side, angle, angle, and side, side, angle. And if I were teaching this in class, I'd say, hey, this one, that side, side, angle, it's going to be weird. And it's going to be easy to remember which one's weird, because if you spell that backwards, you got a little ugly word. Given angle, side, angle, or side, angle, angle, subtract from 180 to get the third angle. Use the law of sines to finish. Easy as pie. That's what we did on those first two. Given side, side, angle, there's a little more information that you need to write down. So on your note card or somewhere in your notes in a big old square, I want you to write, given side, side, angle, use the law of sines to find angle B, subtract from 180 degrees, and A. Check to see if you can make two triangles. If so, solve both. Subtract from 180 and check to see if you can make two triangles. If so, solve both. B, if not, solve the one triangle. Or C, sometimes with the ambiguous case, no triangle is possible. If angle B is not possible, then there is no triangle. Be sure that you have all of that in your notes.